Okay, here is our CC3 Chapter 3 review. This is for a video, but I would like you to fill out the PDF in Cami or on a piece of paper. You can do these problems throughout the video, but just remember that I will move faster throughout this video, so you're going to have to pause throughout, and please don't just copy down my work for the video. Please try the problems on your own and then use the video to check your answers as you go through every problem. Again, also, do not just write down the final answer. That will not help you learn as much as you doing the problem on your own as well. So here we go. Number 1. Solve the equation for x. So the first thing I like to do is draw a line down the equal sign, because whatever you do to one side, you must do to the other. I'm going to write some steps off to the side, and then I'll kind of just copy and paste those steps as I go. So in this case, I do have something I need to distribute. So this is going to be my first step. I see right here I have this negative that is attached to the parentheses that I need to first distribute before I can begin solving for x. So negative times 6x is just going to be a negative 6x there. And then a negative times a negative 4 is going to become a positive 4. And then I'm just going to rewrite all of this stuff down on the right side before we move on to our next step. So now we want to combine any like terms on each side. So if I'm looking on the left side, looking just at the left side, I don't see any like terms because one of those terms has an x and one of them does not. So I'm just going to rewrite them down below because there's nothing we can combine on that left side. But now looking over here on the right side, I see that I can combine the 4x and the 2x. So those two are what we would call like terms. They both have an x. So 4x plus 2x is 6x plus 16. The 16 has nothing to be combined with, so I'm just going to bring it down. So now your next step is to move, and you could really switch the next two steps if you wanted to, but what I like to do first is move all the x terms to one side. Okay, so it does not matter which side you move them to. I think most of you generally default to moving them over to the left side, so I'm going to go ahead and do that here. I'm going to move this 6x over to the left. Since that is a positive 6x, I need to subtract the 6x to move it over. And now you'll notice here where I put the minus 6x. I did not put it underneath the 4 because the 4 does not have an x. So I can only combine it with the other x term. So here now we have negative 6x minus 6x. That is negative 12x. Just going to bring down the 4. 6x minus 6x is 0. And then I'm just going to bring down the 16 here. So now our next step is to move all constants. Constants would be the numbers without a variable. Move all constants to other side, to whichever other side you did not move the x's to. So in this case, I'm going to move my constant term here, this 4. I'm going to move it over to the right-hand side. So instead of plus 4, I'm going to write minus 4. Minus 4. Okay, on the left side, positive 4 minus 4 is just 0. So then I'm going to bring down the negative 12x. 16 minus 4 here is positive 12. So now your very last step is to solve for x. So you have to do whatever you need to do to solve for x. In this instance, I see here that we have a negative 12 times x. So since that is multiplication right here, negative 12 times x, I need to divide both sides by negative 12. Once I do that, negative 12 divided by negative 12 is just a 1. So on the left-hand side, I'm left with 1x equals 12 divided by negative 12 is negative 1. So that is our solution. Now you could always check your solution by plugging in negative 1 for each of the x's up here and making sure that each sides of the equation become the exact same value. But in this case, it does not ask you guys to check your work, so you just have to solve for x. Okay, so I'm going to go ahead and copy this and kind of just, or actually we might be able to see it. Oh yeah, we can see it. So I will use this as we go along, those same steps. So first I want to see, okay, is there anything I need to distribute? So I'm going to draw my line. Okay. Is there anything I need to distribute? I do see that negative 3. So this negative 3 here is attached to my parentheses. So I need to distribute the negative 3 to every term inside of the parentheses. Now this, inside the parentheses here, this is what we would call a trinomial because there are 3 terms. The x is a term, positive 2, and negative 2x. Okay, so we are distributing that negative 3 to each of those pieces. So negative 3 times x is negative 3x. Remember, please pause and try it on your own. Don't forget to do that. Negative 3 times positive 2 is negative 6. And negative 3 times negative 2x is a positive 6x. And on the left-hand side, there's nothing to distribute, so I'm just going to rewrite the left-hand side as it is. Okay. Now we want to see if either of the sides have any like terms. So as I'm looking on the left, again, that the 8x and the 4, there's nothing we can do here. So we're just going to rewrite 8x plus 4. But on the right-hand side, I see that we have 2 x terms we could combine. Negative 3x plus 6x. Now I want to remind you guys, this is where I see a lot of issues. I'll see people try to like add 3x to the negative 3x and the 6x, but you cannot do the same thing on the same side. So here we just combine the like terms that we have. We essentially completely ignore the left side and just combine those like terms on the right. So negative 3x plus 6x, you could also think of it as positive 6x minus 3x will give us a positive 3x. And then this negative 6 has nothing to be combined with, so we'll just bring it down. Now it says move all terms to one side. Again, you could always move them over to the right, but I usually default to moving them over to the left. So if this is a positive 3x here, I'm going to subtract 3x from both sides, like so. Okay, so on the left-hand side, 8x minus 3x is a 5x. Bring down the plus 4. 3x minus 3x is 0. So I just have to bring down the negative 6. So now I need to move all constants to the other side. So here, if I see here, I have the plus 4. So I need to subtract 4 from each side. Okay. So now I'm left on the left-hand side, I'm left with 5x because 4 minus 4 is 0. 5x equals negative 10. Negative 6 minus 4 is negative 10. So now the last step we have is to solve for x. So since this is 5 times x, I need to undo that multiplication by dividing by 5 on both sides. 5 divided by 5 is 1, so I'm left with 1x equals negative 2. Negative 10 divided by 5 is negative 2. So again, please make sure that you have paused throughout and that you actually understand how to do this problem step by step. Okay? All right, so let me go and paste our steps just so you guys have something to follow along with. Okay, so the first thing I would do is draw a line down the equal sign as usual. And we want to check and see, is there anything to distribute? Generally, you're looking for parentheses here. But from what I see here, I don't see anything that we can distribute. But I do see like terms we can combine on the left-hand side. So on the left-hand side, we have 2c and negative c. I just realized this was probably a bad problem to label as C and then use the variable C. This is just part C of the problem, so just ignore that C out there on the left. Okay, so 2C minus C is 2C minus 1C, so I have 1C left. Or you could just write C. So here, the positive 5, oh no, I'm losing my voice. So here, the positive 5, we have C plus 5 because the 5 had no like terms, and neither of these are like terms. So we're just going to rewrite them here. Now the next step is to move all x terms to one side. I guess I should change that and say move all variables to one side. And then down here, I should probably put solve for variable. Okay. So now my next step, I'm going to go and move my c's over. Again, it does not matter which side. I'm just going to go and move them over to the left. So since this is a positive 2c, I'm going to subtract 2c from both sides. 1c minus 2c, 1 minus 2 is negative 1, so we're left with negative c plus 5, these cancel out, equals a 10. And you notice I'm moving a little bit faster because I do expect you to be pausing. Now it says move all constants to the other side, so I'm going to subtract the 5 here to undo that. Okay, these two cancel out. On the left-hand side, I'm only left with the negative c, and then 10 minus 5 is 5, positive 5. But the variable is not completely by itself yet. We technically have a negative 1 out in front there. So I'm going to divide both sides by a negative 1 in order to make this negative be gone. I want that to be a positive c. So positive c equals 5 divided by negative 1 is negative 5. So this would be your solution there. Okay, so now if I slide on over here, we want to see first, is there anything that we can distribute? Okay, and there is. So I see that 3 on the outside of a parenthesis, so I'm going to go and draw my line. And I see the 3 here, so I know I need to distribute that into the binomial. It's called a binomial because there are two terms inside, the 2x and the positive 5. So 3 times 2x is 6x, and 3 times positive 5 is a positive 15. So now I'm just going to bring down this term because it was not inside the parentheses, so I did not distribute the 3 to it. And that is equal to our 2x minus 2. So now our next step is to combine any like terms on each side. So I would just completely ignore the right side. And looking at the left side, I see that I have 15 minus 5, positive 15 minus 5. Those are like terms because they both don't have a variable. So here, 6x is the only x on this side, but 15 minus 5 is a positive 10. So now if we look at the right side again, we'll see, oh, okay, so there are no like terms on the right side because 2x and negative 2, they need to both have an x or neither one has to have an x in order to be like terms. So now we want to move all variables to one side. I'm going to go ahead and subtract 2x from both sides. This cancels out. 6x minus 2x is 4x. And then we bring down the 10, because that one does not have an x. And then we bring down the negative 2. Now our next step is to move all the constants to the other side. So I'm going to subtract 10 from both sides here and here. This one cancels out. 10 minus 10 is 0. We are left with 4x equals negative 2 minus 10 is negative 12. So now we have to solve for the variable. This is 4 times x, so I need to undo the multiplication by dividing both sides by 4. This 4 divided by 4 is 1. So I'm left with 1x equals negative 12 divided by 4 is negative 3. So that is your final answer. Again, please pause the video. You'll hear me say that a lot. But please pause the video so that you get every bit down and you really understand how to do these problems. Alrighty, so here is a word problem where you have to fill in a table, the starting point, the growth, and I'm going to teach you quickly how to write a rule. We've been practicing it throughout the past 2 chapters, actually, kind of secretively. So some of you might be able to write the rule pretty quickly. So let's go ahead and see here. We have Jocelyn moved into a new house and noticed a beautiful vine growing on the back fence. The day she moved in, the vine was 6 inches tall. That's important, so I'm going to go and highlight that. So when she moved in, the vine was 6 inches tall. So the day she walked into that house, she saw the vine outside and it was 6 inches tall. 1 week later, that's important. 1 week later, she measured that the vine was 11 inches tall. She noticed that the vine was growing at a constant rate. Create a table to show the height of the vine beginning with week 0 as the day she moved in. So generally, our x-axis is always our time. So here, our time is measured in weeks. You have to make sure to tell me how it's measured. So our time that's passing is measured in weeks. Whenever she first moved in at 0 weeks, her vine was 6 inches tall. So on the y for this scenario, the y should be the height, and it is in inches. We need to know how they're measuring it. So in the top part there, with all the x values, we say that 1 week later, right? So 1 week later, the vine was 11 inches tall. She also mentioned that it grows at a constant rate. So that means it grows at a constant rate every week. So we want to go week by week up to 4 weeks here. I notice my starting point is 0, 6. Okay, so this right here is my starting point, otherwise known as the y-intercept. So if we were to graph this rule after we get all the points plotted and whatnot, this 0, 6 is your starting point. So I would like you guys to write it as a coordinate always, okay? So the coordinate here is 0, 6, x, y. All right. So now we want to look and see, okay, well, I need to figure out the growth. If it's a constant rate, that means she's telling us it's growing the same amount every week. So to go from 6 to 11, how much did it grow? Pause the video. You should get that it's growing by 5 inches every week. So our growth is a positive 5. So I'm going to write plus 5 inches per week. That is my growth. So if I were to extend this table here, I have 6 to 11, 16, 21, 26. So this tells me that the vine was 16 inches tall at 2 weeks, 21 inches tall at 3 weeks, and 26 inches tall at 4 weeks. So I'm going to remind you guys about the rule of a line. Y equals something x plus or minus something. So we have, I'm going to use green for the growth, M. M is the growth, not mx, just the M. That is our growth. Plus B, whatever the B is your starting point. So pause the video and try to write your own rule, starting with y equals. You should get y equals 5x plus 6. This tells us that we started, the height of the vine started at 6 inches and it grew 5 inches every week. Okay? And that's it for that problem. That's what I was looking for there. All right, Tasha created the equation y equals 2x minus 7 for a table and wondered what the output would be for x equals 7. So if we have a point, we have x comma y. This is what would be a solution on a graph if it worked in the rule. So the x is the input and the y is the output. So it tells us here if x equals 6. So it's giving us the input and we need to find the output. We do not know the output, but if we know that the input is a 6, we can plug in 6 here. Y'all better not be making fun of my voice cracking. It's late at night. I feel like I don't know why it's cracking so much now. All right, there we go. So you plug in a 6. So it's going to look like y equals 2 times 6 minus 7. So now you notice y is the only variable there. That's what we're solving for. So 2 times 6 is 12. So y equals 12 minus 7. 12 minus 7 is 5. So my output here is 5. I'm going to write my output is 5 when my input is 6. Okay, so make sure you get that down. Now number 4 is simply combining like terms. Okay, so number 4, what I would do is color code, just like I taught you guys to do. So I'm just going to start highlighting my terms in different colors. I see here I have an x, a negative 2x, a positive x, and that's it for my x terms. Okay. So you could always write them all out, or you could just do them all in your head for all the oranges. All right, so you could always do that. So I know for oranges I have x minus 2x plus x. So I've seen some students reorder them just like that, and that's totally fine. X minus 2x is negative 1x, plus x is 0x. So those cancel out. Okay. So let me pick a different color here. So I see I have some y's. I have a positive 3y and a negative y. Okay, so positive 3y minus y. Let's see what we end up with. Positive 3y minus y. That should give us a positive 2y. Okay. And then I see that we have negative 2 and plus a positive 6. Okay. So if we have negative 2 plus 6, that is the same as doing positive 6 minus 2. So this is a positive 4. So my final answer here is 2y plus 4. Because 0x, right, all the x's canceled out. So 2y I got from combining my y terms, and 4 I got from combining my constants. And we're done with that one. Oops, I'm sorry. My voice just got really high-pitched. I'm so sorry, guys. I'm tired. All right. Oh my gosh, why is it doing that? Come on, iPad. It's like recognizing my hand as something. Okay, so here I see I have 2a and negative 7a. Okay, so I have, let me make that a little bit bigger here. So 2a minus 7a. 2 minus 7 is negative 5. So here I have negative 5a. Okay, and then I have 3b minus b. So go ahead and try to combine that on your own. 3b minus b should be 2b. And then I just have this little straggler plus 2. So my final answer here is going to be negative 5a plus 2b plus 2. Okay, the negative 5a was the orange part. The 2b was the green. And then I'll go ahead and give the other 2 just its own color here. There we go. All right, so again, I cannot combine these terms anymore because they are in simplest form. All of the like terms have been combined. Okay. All right, so now it says solve each equation. Fractions. Okay, for multiplying fractions, you just multiply straight across. So 1 times 4 is 4. 2 times 5 is 10. I also noticed that these two are both divisible by a 2, so I need to simplify them in order to write them in simplest form. 4 divided by 2 is 2. 10 divided by 2 is 5. So my answer here is 2/5. Now dividing fractions is very similar. We do what is called the keep, change, flip. So we keep the 3/4, we change the symbol to multiplication, and then we flip this fraction. So I'm going to flip it to 2/5. So now if we were to multiply straight across, 3 times 2 is 6, 4 times 5 is 20. I realize that they can both be divided by a 2. That is their greatest common factor. So this gives me 3/10, and that is as far simplest form as I can go. Now for adding fractions together, we have to have like denominators. So here, if I have 1/16, I need to multiply my 3/4 by something on top and bottom to keep it a balanced equation still, but allow me to add it. So in order to get that 4 to become a 16, I need to multiply my top and my bottom by a 4. Okay? So here, I'm going to have 1/16 plus 3 times 4 is 12, 4 times 4 is 16. So now I can actually add my fractions. 1 plus 12 is 13 sixteenths. Okay? The exact same rule goes for subtracting. It's the same idea. So here, if I have 9/11ths minus 5/22, I know that I need to make my smaller denominator the exact same as my bigger one, or find one that they can both become. So here, I'm going to multiply the top and bottom by 2, because 2 times 11 is 22. So this is going to give me 2 times 9 is 18 over 22, minus 5 over 22. So my answer here will be 13 over 22. So that is adding, subtracting, multiplying, and dividing fractions. We've definitely taken notes on these, and these should be review, okay? But please remember, pause the video. All right, diamond problems. So diamond problems, this is the rule of thumb, is if you have any two numbers, let's just call the two numbers x and y, we multiply them to get the top, and we add them, I have to make this a little bit bigger, and then we add them to get the bottom. So here we need to multiply 8 times -8 is -64. And then we need to add, or combine 8 plus -8 is just 8 minus 8. So the bottom here should be 0. So be sure to pause the video and give these all a shot and see what you come up with. Now, if I were to be thinking about 25, I'd be like, okay, well, what factors multiply together to get 25? Because I have to multiply them to get my top number. I know 1 times 25, and then 5 times 5, and that's it. So the only way we can get 0 is if one of those are positive and the other one's a negative. And 5 times -5 is -25. And 5 plus a -5 is 0. Or 5 minus 5 is 0. Okay? So again, we multiply these two to get the top. Oops. And then we add these two or combine them to get the bottom. All right, so then this last one here, since we have to multiply to get the top, we have to divide to go backwards. So -12 divided by 4 is equal to -3. Because whenever you divide like that, you will find out what number that one that was being divisible or being divided on the bottom. Oh my gosh, I just totally lost my train of thought. It is 1 in the morning and I'm losing my train of thought. So The negative 3 is what we need to multiply that 4 by to get negative 12. So that is why negative 12 divided by 4 gave us that other factor. And now if we add them or combine them, 4 minus 3 is 1. And that is your complete diamond problem there. Alrighty, Joshua's parents measured his height as he grew. He grew at a constant rate from the time he was born to when he was 6 years old. When he was born, he was 21 inches long. He grows at a rate of 4 inches per year. How tall will he be at 6 years old? So I see here that my time is in years, and I need to know how old he will be at 6 years old. So I have 1 year, 2 year, 3 year, 4 year. I could continue to add on, or eventually you guys are going to have a rule that you can actually use to solve this problem quickly. But for now, we will just extend our table. Let me see how many more we have left. Okay, cool. All right. And then the height, our height is in inches tall, inches. So whenever he was born, he was 21 inches long. And if we grow at a rate of 4 inches per year, I should be 25 inches tall after 1 year, 29 after 2, 33 after 3 years. So here, I'm going to write plus 4. That is my growth, plus 4. Plus 4. You can also label it down here, plus 4 inches per year. Okay, so he's growing 4 inches every year. So if I keep on going, I'll end up with 37, 41, 45. Okay, so here my starting point, my y-intercept is on the day that Joshua was born. So that's like the day 0, right? Just like all of us, whenever we're born, it's on day 0. We don't become born and then say, oh, it's my first birthday. You know, it's not going to happen. So then our starting point here is 0, 21. Now the rule, again, I'm going to go up here and steal some of my notes here. There it is. Let's see here. Give me just a second here. If you know it, go ahead and give it a shot. Okay, if you already know it, go for it. Let's see if I copied that. Yeah, good. Alrighty. So our rule here is going to be y equals the growth times x plus whatever your starting point was. So my growth here was a 4 per year, and my starting point was 21. So this is my rule. Now, since we wanted to know at 6 years, right? We wanted to know the 6 years piece here. So if we know that x is representing the years, we could have always plugged in a 6 for the x, the number of years. So then we get y equals 4 times 6 instead of the x there, plus 21. So whenever we simplify this, we get y equals 4 times 6 is 24, plus 21. Y equals 45. So that is why I teach you guys how to use a table, a rule, your pattern, whatever might help you solve this problem. Okay? Solve for the output when the input is x equals -3. Well, okay, so I'm going to plug this in here when x equals -3. So that means I have to substitute in. So here we're going to have y equals 4, and then instead of x, it's going to be times -3. plus 5. So here I have y equals 4 times negative 3 is negative 12 plus 5. Y equals negative 7. Okay, so make sure you guys are checking your work. You're checking my work as well. Send me an email if something's wrong. I do appreciate it. Now this one says solve for the input when the output is y equals 5. Okay, so if we have an output instead, that just means that we're plugging that 5 into the y and then solving it just like we did above. So here, if I were to plug in this y, oops, I'm going to have a 5 equals negative 3x plus 2. Okay, 5 equals negative 3x plus 2. So here, all of our variables are already on the right side. So I'm going to go ahead and move away this 2 minus 2 minus 2. This side is going to be a 3 equals negative 3x. So I'm just going to bring this down. 2 minus 2 is 0. So now, if we go ahead and solve for it, we have to divide both sides by negative 3, like that. Negative 3 divided by negative 3 is just a 1. So I'm left with x equals negative 1. Okay? And that's about it for those. So please make sure you get those down and that you fully understand them. Alright, so this one will actually not be on your test. Will it be? Oh, yes, you will have to identify graphs. So I'll do this one relatively quickly. So here, if we have a ruler equation, we want to plug something in to find the output. If my x is negative 3, then I'm going to write 3 times negative 3 minus 3. That would be negative 9 minus 3. Negative 12 is my output. Okay? Then here, if I want to check out negative 2 as my output, I'm going to go ahead and see that 3 times negative 2 is negative 6 minus 3. So negative 6 minus 3 is negative 9. So my output is a negative 9 here. And then you can keep doing the exact same thing every time. What you will start to notice with this one, and I do want you to calculate every single one, I just don't want to take up too much time in this video. So please try this out on your own. And I'm just going to fill in the answers right now. So please pause the video. This is what it should look like. Negative 12 minus 9, negative 6, negative 3, 0, 3, 6. So you need to ensure that you do follow the rule to a T, okay? So you can plug in your different inputs in for X, and then that will help you find your outputs. So here we need to have a nice complete graph. X and Y are labeled. Let's go ahead and write, I'm just going to write some numbers down here. Okay. All right, so there's those. And then going up, I'm just going to go by ones just to play it kind of safe. Which, like down there, I did go by ones, but I did make them skip just so that we can see a bit of a bigger graph there. Okay, so I could keep on going, but I'm going to go ahead and stop here. So negative 1, negative 2, negative 3, and so on. So my first point is negative 3, negative 12. But I don't know if there's going to be 12, so let's see here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're almost there, okay? So I cannot plot that point, and that's totally fine, right? You only need 2 points to plot a line. So then I have negative 2 and then negative 9. So negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. All right, so here I'm going to plot the negative 2 comma negative 9. So negative 2 down to the, oops, I forgot I skipped some. The only reason why I skipped on the x-axis was just so I had a little bit more room to see, oops, what was I saying there? Oh, just so I can see the line a little bit more clearly. so that my points are not all bunched together there. All right, so if I go back to -1 down to -6, that's another point. 0, -3. I'm getting these from our table there. 1, 0, that's my x-intercept. 2, 3, and 3, 6. All right, so these are the points, and this is the line you should have gotten. Okay, I'm not going to do the second one just for sake of time, but you will be given a graph such as this one and be asked to tell me the rule or to tell me, you know, what you notice about it exactly. So please prepare for that. All right, last but certainly not least, we are going to evaluate these expressions. So I'm going to go ahead and color code. So I'm going to do all my m's in green. So I'm plugging in this m every time. Okay. M, there we go. Okay. Alrighty. And then I'm going to go ahead and plug in all of my, or just highlight all my P's here. P, P, and P. Okay, so here we have that P equals 5 and M equals -2. So here's what I'm going to do here. I'm going to do 4 times -2 minus 3, and then let's go here. Yeah, it's going to be this kind of minus 3 times the P is 5. Okay, so 4 times -2 minus 3 times 5. This would be -8 minus 15, which is -23. Remember, calculators are fair game, so make sure you're familiar with using that Desmos scientific calculator. Alrighty, so here we have m divided by 2. Okay, that does work good. -2 divided by 2. All right, because that green up here, that green is the m, and that's what we're plugging in. Okay, and then plus 2 times 5, because that is the orange. Okay, and then I'm going to go ahead and minus 3. So if we were to simplify this, we're going to get -1 plus 10 minus 3. So what we want to do here is do -1 plus 10 is 9, minus 3 is 6. Guys, I'm so tired. I'm like sitting here waiting for you to answer. That's what I was just doing. I hope some of you guys think that's funny. I like making you guys laugh. Okie dokie. So let's see here. So that's the answer there. I'm like literally starting to kind of like fall asleep at the same time. I don't know if I've told you guys. Like over here, like why did I put the green there? I have no idea. No idea. All right. So now if we were to solve the next one, so we have 20 over 2 instead of P, it is a 5 minus 3 times -2. Okay, so now we have to simplify here. So 20 over 2 times 5, this would be 20 over 10. And then -3 times -2 is +6. This would be 2 plus 6, which is 8 for that one. Okay. So now another one. So P plus 2M equals blank. So here the P is a 5 and the M is -2. Okay. So here's the 5 there. And then the -2 right here. So this is going to be 5 and then -2 minus 2 is going to be -4. So 5 minus 4 is 1. Okay, so these are how to do these problems. Hopefully I did not make a mistake anywhere, but if I did and you catch it, please let me know. I would really, really appreciate it. Try to do this one on your first if you can. And I think that sums up chapter 3 for us. Okay, have a good one. Thank you.